Saxon Algebra 2, lesson 101. The topic is percent markups, but what I want to tell you, sorry, I was looking at the wrong paper. What I want to tell you is that this is a category of what I would call business math. Okay? It is not difficult in terms of the mathematics. That's actually really easy. The only tricky part to this is just making sure we understand how the terminology works, right? The trick to making sense of these is to put yourself in this perspective, not of the customer, which is what you're used to being, but you now own a store. You are the store owner. Okay, that changes your perspective a little bit, and these terms will make a bit more sense if you keep that in mind. Let's assume it's a Zumiez type store. Zumiez is a store, I think they have some of their own brands, but mostly they buy other companies' merchandise, Vans, North Face, Roxy, right? They buy brands that other companies manufacture, and then they sell them in their stores, right? Zumiez is a perfect example of the kind of store that we are operating here. Okay, so in order to get anything to sell in our store, we have to buy it first from somebody who manufactured it, and then we have to adjust the price, right? Because we need to make some money on this, so we need to sell it for more than we paid for it. And that's where I want to kick into our definitions. When we're figuring out our selling price, which is, in other words, the number on the price tag that we're going to put on it. When our customers come into Zumiez, that's what they're going to see on the tag. That is equal to the purchase price. Now that's the purchase we pay, the price we paid for it. Right? When we bought it from North Face or Burton or whoever, we had to pay them. That's our purchase price because we're the store owner. And then we have to add to that what's called a markup. And this markup is what covers all our expenses. Okay, we have to pay people to unbox the merchandise and get it ready for the floor. We have to pay people to wait on customers. We have to pay the utilities, right, to keep the lights on in our store. We have to pay the mall to rent our store. We have to pay for insurance so that if our customers poke their eyes out with one of our hangers, we're covered, right? The markup is where we have to make sure we get all of our expenses paid. This is what we pay. In business, we use the word goods, meaning whatever it is that you're selling, right? So with Zumiez, the purchase price is what we paid for the goods, and the goods could be skateboards or snowboard bindings or cool t-shirts or, anything. Goods are the things that we sell. And the selling price is the price on the tag. Right? That's what we sell it for to our customers. All right? So these three components are the fundamental numbers that a store has to look at when they're making sure that they make money. Now, here's the thing. Sometimes they're quoted as percentages of each other, and that can change. The markup can be a percentage of the purchase price. The markup can be a percentage of the selling price, for example. So we have to, when we're doing these calculations, pay close attention to how these things are structured so that we're making the right kinds of calculations. Again, the numbers aren't hard. It's just keeping our heads on straight and understanding these numbers. Make sure you capture this idea, because this is kind of the fundamental relationship that we use in this lesson to make sense of it. Example 101.1. The selling price was 48. SP equals $48. If the markup is 20% of the purchase price, what was the purchase price and what was the markup? Okay, so we can see we've got some information, but not a complete set. So the first thing I'm gonna do is show you a way we can abbreviate this to make it easier. Selling price equals purchase price plus markup. All right, so that's what we're gonna use to help organize our numbers here. We know the selling price and we know something about the markup. So what we're gonna do is plug into this. So we'll have 48 equals the purchase price, we don't know that, plus the markup, and the markup we know is 20% of the purchase price. So I'm gonna write that as a decimal, but otherwise I'm just writing that. Our selling price equals the purchase price, we don't know, plus 20% of the purchase price, because that's what the markup is. All right, so how do we solve this? Well, we recognize that there's an invisible 1 in front of this, and we can add these as like terms because they're both purchase price. And by the way here, these don't represent two different variables. We're using two letters for each variable, right? SP equals PP plus MU. We're just using two letter variables. So we can add those together. 48 equals, look, 1 plus 0.2, 1.2 times the purchase price. Oh, that makes it so easy. Now we just divide by 1.2. And we get that the purchase price equals $40, right? 48 divided by 12, let me just make that 12, that would be 4, but this is smaller than 12, so my number is bigger than 4 by 1 decimal place in each area. If you need to do the long division, do it, that's fine. So the purchase price is $40. Oh, that makes sense. And now the markup, now we can actually calculate it. We know it's 20% of the purchase price, which is 40. So the markup is $8. Beautiful. The other way we could find the markup is it equals the selling price minus the purchase price, right? We can mentally rearrange that, subtract that, and that would be 48 minus 40, so that's another way to get the $8, okay? Again, like I said, the math in these problems is not difficult. It's just understanding how to use the terms. All right, purchase price is 40, markup is 8. There are 3 in all. Example 101.2. And I'm gonna write this down again. Selling price equals the purchase price plus the markup. My phone's a little crooked. Okay. The purchase price of the item was $1,800. I wonder what we could sell at Zoomies for $1,800. That's a lot, even for like a snowboard or skis. Maybe it's a package. If the markup was 40% of the selling price, now that's different. Last time the markup was a percentage of the selling price. It's okay, no big deal. We can figure this out. What was the selling price? Okay. Well, we know the selling price, I'm using this, equals the purchase price, 1,800, plus 0.4 of the selling price, right? That's 40% is 0.4 times the selling price. Okay, so what do we do with that? Well, we see, oh look, these variables are the same. This has an invisible 1 in front of it. What if we subtract the 0.4 SP? This is gone. this becomes, I'm going to put a 0 in front of it, just it looks a little bit nicer. All right, 1 minus 0.4 is 0.6. And now we just divide both sides by 0.6. And we find out that the selling price, okay, again, this is the way that I do it. 6 into this would be $300, right? But this is one jump smaller than 6. So my answer is one jump larger than 300. So this would be $3,000 is our selling price. And so then what would our markup be? Our markup is 40%. So 3,000 times 0.4, I'll do it out, right? 0, 0, 0, 12, and then put 1 decimal place in the answer. So our markup equals 1,200. And again, we could also have found that by saying the markup equals the selling price minus the purchase price. We found the selling price was 3,000, and we know the purchase price is 1,800. So this is another way we can calculate that the markup is $1,200. One is not better than the other. Whichever one you want to do is fine. Oh. So these are kind of weird, right? Each one's a little bit different. We're going to do one more. And we have to just keep this in mind and then use logic to fill in the equation. And then we get one answer, and then we just have to use that to create the other answers. Again, using logic and common sense. The math isn't hard. It's just a matter of understanding the terms. Let me switch. Example 101.3. This is the last one for this lesson. The sports car retailed for, let me just say this. When we say something retailed, that means it's the price to the retail customers. So that is the selling price. It's the price on the sticker or the tag. The sports car retailed for $10,368. So the selling price equals $10,368. That is a laughable number, isn't it? We should have another power of 10 on this, because a cool sports car now would easily cost over $100,000. Sad, isn't it? I'd like a sports car. This is my dream, to get a really, really, really fast car. A Lambo, a Maserati, something really fast, and keep it in a garage in the desert somewhere, like, I don't know, Arizona or Nevada, where there's no people, there's no country, and the weather is relatively mild. And then, every now and then, I would drive or fly down to my garage and take out my car and drive like a maniac for days at a time. And then put my car back in the garage and come home. I don't want a Lambo to drive to the grocery store, but I love to drive really fast. I will not lie. And I love to drive in wide open country like that. Okay, so I'm gonna buy my sports car for $10,000. Yeah, right. We're supposed to find out what is the purchase price if the car had been marked up 8% of the purchase price. So the markup equals 8% of the purchase price. All right, so once again, we're having to just kind of figure this out as we go. We know this is the selling price, so that goes, let me write my equation again. Selling price equals the purchase price plus the markup. That's what you need to remember. Selling price is $10,368. That equals the purchase price, which we don't know anything about, plus the markup is back to being a percent of the purchase price. So we would write 0.08, right? This is 8%. If we write 0.8, that's 80%. So we have to be careful with our percents times the purchase price. All right. This has an invisible 1. So we can write this by adding these like terms together. 1.08 times the purchase price, right? I add them together. Now we divide both sides by 1.08. Don't worry, it comes out real nice. Okay, these cancel. 10,368 divided by 1.08. Remember the way we do this is we have to bump the decimals over, add them so we can bump them over here, and then once we get it settled, we take it right up there. Okay. How many times does 108 go into 103? Well, it doesn't go in once, so we must have to go here and do 9. Let's check it out. 9 times 8 is 72. 0 plus 7 is 7, and then 9. Okay, we lined that up just the way we wanted. That worked out well. If you ever put the number in the wrong place and it doesn't line up right, just adjust. It's no big deal. Now we subtract. 4, this becomes a 9. 6, 4, 8. We'll have to bring down an 8, and then we're going to have to bring, no, that's fine. We can do this. Oh, wait a minute. I look at the 6, I think 6, because 6 times 1 would give us the 600, and then I look, oh, 6 times 8 is 48. I think this is going to work out even. 9, so I'm multiplying 6 times 8 is 48. I'm carrying the 4, forget about the 7. 6 times 0 is 0 plus 4. 6 times 1 is 6. Look, it turned out even. So now we just have to fill in the last few decimal places. And we get that, we were solving for the purchase price. The purchase price equals $9,600. We know the selling price, so I'm going to write that down as well. 10,368. And then we need to know the markup. We could multiply 8% times this, but I'd rather just subtract, wouldn't you? The selling price minus the purchase price equals the markup. And that would be 768. And we put dollars when we're doing problems about business, about money. We always put dollar signs at the beginning and at the end. We don't have to put them all the way through. Did you know, I don't know if I've told you this, I was an accounting major in college and I worked in the world of accounting. I worked for a public accounting firm, which was way more fun than you probably would guess. In my 20s, that was my corporate career. It was really fun and I enjoyed it. And accounting's not boring, so don't let anyone tell you that it is. Okay, that is the end of lesson 101. We are not really going to build on that. I think there's another lesson or two that talk about other aspects of business math, but this selling price equals the purchase price plus the markup, that's all we're going to do with this. All right, goodbye.